Hello APC Mechanics students in Unit 1, Class 2, Motion in One Dimension, Part 2. Then in today's lecture we're gonna discuss some graphical interpretation that is crucial for motion along one dimension or kinematics in general. Then first, let's start with section 1, which is the straight line linearity. We know that the equation of a straight line is given by y is mx plus b, and that would be the graphical representation of the straight line. M is given by the slope and b is the y-intercept. Now the word intercept means it is an intersection. Then basically this point, which is given by the coordinates 0b, would represent the y-intercept, which means the intersection with the y-axis, and the x-intercept, which is this point basically, would represent the x-intercept. However, the x-intercept doesn't appear explicitly in this equation. Now, what about the slope calculation, which is denoted by m? Now, the first thing that we should do is that we need to choose any 2 points belonging to the straight line, whether they are close enough or far away. Then that would be the first point and that would be the second point. And the slope can be computed using the following formula. That would be y2 minus y1 over x2 minus x1, or you can do it the following way: y1 minus y2 over x1 minus x2, respecting the order. Now remember that in physics the slope has unit, and I wanted to mention the following is that after choosing 2 points, try to manage your calculation in an efficient way, and that can be only attained by practice. Always, whenever you face problems that are repetitive, like slope calculation, try to find a specific skill or a shortcut in order to save time. Now let's take a look at the following example. Example 1. For each of the following intervals, 0 to 4, 4 to 6, 6 to 10, determine the slope of the given curve. Then why we have divided this curve into the following intervals? The thing is that for each interval 0 to 4, 4 to 6, 6 to 10, the slope of the curve changes. Now I didn't correlate the slope with any physical quantity. Later we're gonna do that. Now this example is just to demonstrate how you can calculate the slope in an efficient way. Now we're in the interval 0 to 4, so then we need to choose 2 points along this interval. Now we choose a point and we're gonna directly write its coordinates here. We choose another point and we're gonna directly also write its coordinates. Then the slope would be given by, now for me I would rather do minus 2 minus 6, so this number minus this number over this number minus this number. Then that would be negative 2 minus 6 over 4 minus 0, and the slope in this case would be given by negative 8 over 4, and that would be negative 2, and the unit in this case would be meter per second, which is given by meter per second square. So here in this case we start noticing that the slope has a unit, and more importantly, if we're trying to read this curve, for sure we read it from left to right. As we can see, we're going down. For this reason the slope has a negative sign, and this will be interpreted later. Now let's consider the interval 4 to 6. Okay, the thing is that we're gonna choose a point here, for example, and that would be 4 and negative 2. Then we directly write the coordinates. Another point would be 6 and negative 2, and now we're ready to calculate the slope. Then according to my way, that would be negative 2 minus negative 2 over 6 minus 4, and that would be 0 over 2, that would be 0, and here notice that it is 0 meter per second square, but anything multiplied by 0 is 0. Now here the slope of this line is 0 because it's a horizontal line. Now for the final interval, according to the previous interpretation, we expect that the slope of this line should be positive. Then let's choose a point and write its coordinate. Choose another point and write its coordinates. And now we're ready to calculate the slope. That would be 2 minus negative 2 over 10 minus 6. That would give us 4 over 4, that would be 1, and the unit is given by meter per second square, and as anticipated, the slope of this line is positive. Now accordingly, we can do the following conclusions in section 2, slope, which is steepness of a straight line. The slope can be understood as a ramp or an inclined plane, and this is what meant by the steepness. Now if you consider the first one, and we're reading the graph from left to right as if it's a ramp going up, for this reason the slope is positive. Whereas for this one, it's not a ramp, it's a level surface, so it has no slope, it's a horizontal line, we expect that the slope is 0. However, for this one, we're reading it from left to right, it's a ramp but it's going down, then the slope in this case would be negative. Now what about a completely vertical line? So if you want to go up this line, this will take you an infinite amount of energy or work. For this reason, this is an infinite slope. Now here we have two curves, we have the green one and we have the red one, and remember that we read it from left to right. The slope of the green line is greater than the red line. For this reason we say slope 1 is greater than slope 2. And in this case, if we're reading it from left to right as we do always, we notice that the green line has a slope greater than the red line. And that would be slope 1 is greater than slope 2. Now the physical meaning of the slope. The physical significance of the slope can be determined by the ratio y over x. This applies for both a straight line and a nonlinear curve. Remember that the slope calculation that we've introduced previously only works if the line is a straight line. Now this method, which is the physical meaning, applies for any curve. Let's consider the following example. Now determine what physical quantity does the slope represent. In order to do so, we need to consider the ratio y over x, and in this case it's velocity over time. That would be v over t, and we know that v over t is simply acceleration. Then in this case the slope is velocity over time, which is acceleration. Another example would be, notice here the shape of the curve is nonlinear. What does the slope represent? It's vx over t, then it's basically ax. Now here similarly we need to determine the interpretation of the slope. That would be position over time, which is basically vx. Now here the slope would be vy over t, which is ay. Now example 2, the velocities of cars A and B are plotted. Number 1, state the initial and the final velocity of each car. Number 2, we need to determine the acceleration of each car. Now before we get into number 1 and number 2, let's take a look at the graph. The shape of the curves are straight lines, so basically we need to make use of the slope. We might make use of the slope as well as the y-intercept, which is the v-intercept in this case, and the x-intercept, which is the t-intercept. In number 1, they're telling us to state the initial and the final velocity of each car. That would be the initial and that would be the final. If you consider car A, the initial velocity is 12 and the final velocity it meets with the t-axis, then it would be 0. And as for car B, the initial velocity is minus 12 and the final velocity would be 0 as well. Now we need to determine the acceleration of each car. Then this is a VT graph. So how we can determine the acceleration? Because it's a straight line, let's interpret the slope. Then in this case the slope would be given by v over t, which is basically the acceleration. So in other words, if we determine the slope, then we have determined the acceleration of each car. Let's start with car A. Here what I'm doing is that I'm interpreting that the slope is the acceleration. And in order to do so, we need to choose 2 points. This is my first point here. I'm gonna write the coordinates here. This is the second point. And I will write the coordinates as well. Now we're ready to calculate the slope. That would be 0 minus 12 over 8 minus 0. That would be negative 12 over 8, and that would be minus 1.33 meter per second square. And the acceleration here is negative because the acceleration is the slope and the slope is going down. Now as for car B, also we need to choose 2 points. Then this is the first point. we write the coordinates. This is the second point, we write the coordinates, and now we're ready to calculate the slope. That would be a of b, 0 minus negative 12 over 8 minus 0, and that would be 12 over 8, and that would be 1.33 meter per second square. Now section 4, position, velocity and acceleration time graphs. It is important to interpret and analyze the xt, vt and at graphs correlated with the type of motion. Then it is important to remember and interpret the shape of the curves of zero and constant non-zero acceleration. Now let me write here the following order that I will refer to it later. 0 followed by constant, followed by linear, and followed by quadratic. Now section 4.1, uniform motion. Whenever we say uniform motion, this means that the acceleration is 0, and that would yield a constant velocity. And whenever the velocity is constant, we have two cases: either it's positive and constant, either it's negative and constant. Now first case, positive constant velocity. Now because the velocity is constant, which means that the acceleration is 0 at all times, then it is represented by a zero horizontal line, this bold line which is represented here. Now what about the velocity? The velocity is constant. Constant means it is represented by horizontal line, but this horizontal line would be positive, which means it's shifted upward like that. And this is the curve. And remember that whenever we're talking about velocity, we're talking about the direction of motion. Here the velocity is positive, which means that the direction of motion would be in the positive direction. Now what about the position? Now, okay, we can use the following sequence. If it's constant, then the one it follows it would be linear. Then the shape of the xt graph would be linear, and this is anticipated. Why? Because of the velocity is 4 meters per second, which means that the position each second is gonna increase or decrease by 4 meters. In this case it's an increase, then this means it's a linear relationship. Then the shape of the curve would be a straight line, and it's either gonna be like that or like that. Velocity is positive, which means it is increasing, then the shape of the position would be something like that. Notice that an increasing straight line might be represented like that, or like that, or like that, but the more general case is to start from a negative position. Now here let me write that this is 0, this is constant, and this is linear. So we have moved in this order, which is from A to V to X. Now in the case of negative constant velocity, let me write the order: 0 to constant to linear to quadratic, and we are following the path from A to V to T. Now constant velocity, it means that the acceleration is 0 at all times, which is represented by a zero horizontal line. Velocity is constant, it's horizontal line, but it's either shifted upward or downward. Negative, which means it's shifted downward. Now velocity is related to the direction of motion. Now here the velocity is negative, which means that the direction of motion is in the negative direction. Now, so that would be 0, and that would be constant. We know that constant will be followed by linear. Then the shape of the xt graph would be linear, and this can be anticipated because if the velocity is constant, let's say 4 meters per second, that the position is gonna change 4 meters each second. It's gonna be a straight line like this or like that. Velocity is negative, then it is decreasing. Then the shape for the xt graph would be something like that. Notice that we would represent the straight line to be like this or like this, but a more general case is to start from the positive initial position. Now section 4.2, uniform varied motion. Before we proceed, let me write the order that we're moving with: 0, constant, linear, quadratic, and this order is for A, V, and X. Alright? Now, Okay, uniform valid motion means that the acceleration is constant, and we have two cases, either positive constant acceleration or negative constant acceleration. Then constant acceleration, it is represented by horizontal line, either shifted upward or downward. Positive, it means that it's shifted upward. Then the shape for the AT graph would be something like that. Now, if we're respecting this order, constant, it means the next corresponding shape would be a linear, which means something either like this or like that. Because if the acceleration is, say, for example, 2 meters per second square, which means 2 meters per second, then the velocity is gonna either increase or decrease at a rate of 2 meters per second. Because the acceleration is, which means it's a linear, it's a straight line. The acceleration is positive, then it's an increasing straight line. We could have represented like that or like that, but a more general case to start from a negative value. Now, whenever we're talking about velocity, we're talking about the direction of motion. Here we can split it into two portions. This portion as well as this portion. Here the velocity is negative, which means that the direction of motion is in the negative direction. Here the velocity is positive, which means that the direction of motion is in the positive direction. And this point, which has a zero value, it's the point of change of direction. Now again, if we're respecting this order linear, then the one followed would be quadratic. Then the shape for the xt graph would be quadratic. Quadratic means it's a parabola. It's either like that or like that. This is a quadratic opened up, and this is opened down. This corresponds for a positive acceleration, and this corresponds for a negative acceleration. Now we're in the case of the positive acceleration, so it will the shape will be something like this. But now notice that initially the velocity is negative, which means that the position will decrease. Then it's gonna do like this. And after that, the velocity will increase. It would be something like this. Then the shape for the xt graph, we would expect it to be a quadratic function open upward. In the first portion, it will be decreasing, and in the second portion, it would be increasing. Now, second case, negative constant acceleration. Constant acceleration means that the acceleration would be represented by a horizontal line. Negative, it means that this horizontal line will be shifted downward. Let me write the order that we're following. 0 constant. Oops. 0 constant, linear, then quadratic, and this corresponds for a to v to x. Now, okay, we know that after the constant we're gonna have a linear. Then the shape for the vt, it's either gonna be like this or like that. Acceleration is negative, then it would be decreasing, and this is anticipated. If it's a constant acceleration, then the velocity is gonna increase or decrease at a steady rate. A more general case to start from a positive initial value, since it's decreasing, we can split it into two portions. Here the velocity is positive, and here the velocity is negative. Whenever we're talking about velocity, we're talking about the direction of motion. So in this case, the direction of motion is positive. In this case, the direction of motion is negative. And this is point where the velocity is 0. It's the point of change of direction. Now, if we're moving again with the same order, linear quadratic, so the shape of the curve is gonna either be like this or like that. This is positive acceleration. This is negative acceleration. We are in this case. Then the shape, it's gonna be like this. So here, the velocity is positive, which means that the position is increasing. In the first portion, it would be something like that. And here, the velocity is negative. In the second portion, it would be decreasing. Now, exercise 1, an object is moving along a straight line. The object's velocity as function of time is shown in the graph. The object has a speed of 2 meters per second at which of the following intervals? Now, always whenever we see the terms velocity and speed, we should be very careful, because we know that they share some common properties that are basically the magnitude, but the velocity encodes more information. They're asking for the speed of 2 meters per second. Then that would be this horizontal line. and that would be also this horizontal line. Now here the velocity is -2, but its magnitude, which is the speed, is gonna be 2 meters per second. Then in this case we have 1 second, 6 seconds and 9 seconds, and the correct answer would be E. If they're asking for the velocity to be 2 meters per second, then that would be at the time 9 seconds solely. Okay, now exercise 2. An object is moving along a straight line. The object's velocity as function of time is shown in the graph. During which of the labeled segments on the graph is the object moving but not accelerating? Remember that if it's not accelerating, the velocity should be represented by a horizontal line. Here we have two horizontal lines, B and D, but D here it's not moving, V is 0. Here at B it's moving, but with 0 acceleration, constant velocity, and that correct answer would be B. Now the graph above shows velocity as function of time for an object moving along a straight line. For which of the following sections of the graph is the acceleration constant and non-zero? If the acceleration is constant and not 0, so A is different than 0, A is constant, then we expect that the shape of the curve is going to be either like this or like that for a VT graph. Then the correct choice would be D, because RS and ST represents linear curves. Now the graph above shows the velocity as a function of time for a car moving on a straight horizontal track. At which label point does the velocity of the car change direction? Remember that an object changes direction if and only if the velocity vanishes, and this happens to be the point C. Now exercise 5. The graph above shows velocity as function of time for a cart moving on a straight horizontal track. At which label point does the cart have the greatest speed? Now whenever we have velocity and speed, we need to be very careful, because we know that these two are related to each other. Velocity encodes more information, speed is the magnitude of the velocity. Basically the point B has Vmax, the maximum velocity, and D has the minimum velocity. The best way to approach this problem or such type of problems is to give numbers. Let me say that this is 3 meters per second, and let me say that this is minus 8 meters per second. Here if we're comparing the velocities, B would be the greatest velocity and D would be the lowest velocity. However, if we're talking about speeds, the speed of the point B of the point D would be greater than the speed of the point B. Now here in the question they are referring to the speeds. For this case the point D has the greatest speed. Then D would be the correct answer. Then thank you for watching and see you soon in a new one.